McCormack with the Riverhawk Company. We're going to demonstrate our hydraulic rod tensioner today. This is a Riverhawk patented item that we are the only source of this type of tensioner. What you'll see the difference of the HRT tensioner. The HRT, one of the main benefits of the HRT is it's designed to fit within the same spot face of the original nut. If this was the customer's original nut, you'll see that the whole tensioner isn't any larger than the nut itself. To compare it to a legacy style tensioner, this is very commonly found in the industry. You'll have the hex nut and you need all this thread exposed to tension it. But the tensioner has to fit over the nut. Whereas I was showing on the HRT tensioner, the HRT fits within the same spot face as you see of this hex nut. And also the HRT tensioner doesn't need all this thread exposed, and I'll demonstrate all that. The reason all this thread is exposed is because this stud was designed to be tensioned. The big tensioner has to go over the stud, over the nut, so you need a large footprint and threads exposed for the puller screw to grab onto the stud so you can tension it. On many applications out in the industry, you don't have the threads exposed and you don't have a footprint around the hex nut. So a lot of people would think that you can't tension a nut like that. Riverhawk has come up with this technology. We call it the hydraulic rod tensioner because I'm going to take off the hex nut and I'm going to put on a special nut. This is called a perforated nut. It replaces the hex nut and allows the tensioner to fit just over the outside of it and tension the stud. The whole diameter of the tensioner as well as the nut is no larger than the footprint of your hex nut. So what we have for component wise, we have the actual tensioner. This is just a simple hydraulic load cell. We have what we call the pin platform that goes through the nut. This is how we're going to actually tension the stud. You can see the pins push through the nut and will be the force acting to stretch the stud, of which we'll demonstrate. Once we do that, this is actually going to replace your nut. This is a retaining ring. The retaining ring and the nut are always assembled, so we ship them assembled because this is going to replace the nut when we take off your hex nut. This retaining ring, once we stretch the stud, you'll bring this down to lock the tension that you've just put into that stud. This is a hardened steel washer because we don't want to dimple the flange face of the customer, so we use this special hardened steel washer for these pins to push off of. And I'll demonstrate all this as we go through the process. So as I said, we'll take off the customer's nut. You see there's no threads exposed, so you couldn't use a normal style tensioner. We'll take the nut off. And then we're going to install the hardened steel washer. As I said, we put this hardened steel washer on because we don't want our pins that the tensioner is going to push on to dimple the flange face. Once we put the hardened steel washer on, we want to install the nut. We call this the hydraulic rod nut. That's a hydraulic rod tensioner. So this is a special nut that you'll see with all the perforated holes for our pin platform to go through. So we took off the customer nut, we put on our perforated nut. You want to thread the nut all the way down until it comes into contact with the washer. Once it comes into contact with the washer, what we want you to do is to back this off 1/4 of a turn. Why we say to do that is because we don't want the nut here. This nut should never have any load to it. So when you back it off 1/4 of a turn, it allows a slight space between the flange face and the nut, which will eliminate it ever getting seized on or getting stuck in place. Once you do that, holding the nut, you want to bring the lock ring down. Once you bring the lock ring down, take your spanner wrench, put it on, and this will just give it a snug. That makes it locked in place, so now it won't turn or move. The next thing you want to do is take the pin platform. The pin platform has several pins. What we're going to do is push through the nut. So instead of the tensioner, a big bulky tensioner going around the original heavy hex nut, we have actually come up with this design of the pin, the HRT rod, hydraulic rod tensioner platform, to go through the nut. It could be a little tricky trying to get the holes lined up. If you kind of put it at an angle, you'll see that it falls right in place. So what we're going to do is put a load cell, the tensioner itself, on here. The load cell is going to grab on these threads that you see right here, push on the rod platform, stretching the stud. So once we put the pin platform in, we thread the tensioner on. Now you thread the tensioner right down onto the locking ring. It doesn't have to be tight, just down snug. Once you've done that, it's ready to tension. Hook up your hydraulic hose. Now we will specify an exact pressure that you're going to go to on our installation drawing that you'll get with any hydraulic rod tensioner that we design. We're going to have a very specific pressure. It might be 15,700 psi or any type of particular pressure that was calculated to give you the exact clamping force required for the joint that you're going to tension. What we're going to do is just bring it up to about 3,000 psi. You'll see that the retaining ring is down tight, down snug. This retaining ring is what's going to maintain the tension in the stud. You'll see as I bring the pressure up, the tensioner is going to push the pins through that nut that you saw me put on and stretch the stud. The retaining ring will lift off of the flange face. Roughly 3,000 psi, and you'll see that the ring, I'm turning it by hand a little bit, so you just snug it down. That is all you really need to do to tension the stud. Release the pressure, remove the hose, remove your wrench in the tensioner body. Pull the pin platform off. Now you very easily could go right to the very next stud with your pin platform into the nut that you have changed over and put the tensioner on and keep going around. That is tensioning with an HRT. Okay, for the removal process, pretty much the same as the installation, obviously in reverse. One thing to point out, usually we'll have a cover that's going to go over the nut. When all the nuts are done and tensioned, there's a cover, and we can make it out of aluminum. It could even be out of plastic depending on temperature. Any low-grade steel because there's no stress or anything on it. But we put a cover on to protect the holes from getting filled with corrosion as well as the threads from being damaged. We don't do it on the demo, but all the HRTs that we supply, we also supply with some type of cover. So if we're going to remove this, a real application, obviously the first thing is you take the cover off and then you put your pin platform in. The pin platform goes in that easily. You thread the tensioner on. And one thing you'll want to remember is the strap wrench. A lot of times people will get going so fast doing this, you hook the hose up, you put the pressure on to start removing the tension, and you don't have the wrench on to remove the lock ring. We also make a lock ring that would have holes in it. You can actually use a pin wrench, so you don't need to use the strap wrench. This particular design, we have a strap wrench that goes over it. So you put your hydraulic pressure on. Just as we had a installation pressure that was stated on the drawing, you'd want to look that up before you started detensioning the studs. That gives you an idea what pressure to go to remove the tension. So we did just about 3,000 psi, whatever the drawing says for your installation. You'd want to go to roughly that pressure, maybe slightly over it to relieve the tension in the stud. So we'll bring the pressure up. One way to tell why you're doing it, you can actually put the wrench on, and as you bring the pressure up, you'll see that the wrench came right loose there. That shows that the tension is now into the hydraulic tensioner and lifted it off of the retainer. Once you do that, you can release the pressure. Remove your hydraulic hose. Remove your strap wrench. Now remove the tensioner. Sometimes the nut will come right off with the tensioner. It's not a big deal if it does. Remove your pin platform. If the nut was to come off with the tensioner, being there's no tension, no load there, you're simply threading them by hand to thread it off. That is detensioning the stud.